In the previous video, I had explained about how to draw the circuit for analyzing the transistor characteristics. Now we are going to see how to find out the parameters of the transistor. The first parameter of the transistor is input impedance. To find out the input impedance of the transistor, we have to draw a graph. From the graph alone, we are going to find out the input impedance of the transistor. The graph which is required to find out the input impedance is called input characteristics curve or graph. So the name of the graph is called input characteristics. Here in this circuit, you should know about which one is input part and which one is output part. This part of the transistor circuit is called input part. This part of the circuit is called output part. Are you clear? So here, this is the tabular column. In this tabular column alone, we are going to observe the reading and note down the reading. Here, this is the input region now. Here, across the base and emitter, one voltmeter is connected. And the current which is flowing through the input part is called base current. Are you clear? So to find out the input impedance, first we have to find out the formula. The basic fundamental formula is Ohm's law. From Ohm's law alone, we are going to find out the formula. V is equal to I into R. This is the Ohm's law fundamental formula. Here, V is voltage, I is the current, R is the resistance. Here, in the input region, to the flow of that current IB, some amount of opposition is there. That net opposition offered in the input region is called impedance. Impedance is also a kind of resistance. Therefore, V is equal to I into, instead of R, we can use, is it clear, some other symbol. Instead of R, we can use the symbol as given in the textbook. In the textbook, the input impedance symbol is Ri. Small ri is used. Small ri is used. This is a symbol called input impedance. Here, V, I, Ri, everything is written. Ri can be written as input impedance. Ri can be written as V divided by I can be written. Since it is input impedance, we have to find out which one is the voltage in the input region. Voltage across base and emitter is there. Therefore, here we can write it as VBE can be written. Instead of V simply written as V, we can write it as VBE. Which current is flowing in the input circuit? Base current. Therefore, VBE is already written instead of I. The base current is the input current now, IB can be written. Here, in the numerator, we have to write the del symbol. Del is for difference in. Del, that one gives you the difference in VBE, and del IB is called difference in base current. So this is the required formula to find out the input impedance. Are you clear? Ri is equal to del VBE divided by del IB is the formula. Since it is impedance, it's a kind of resistance. This one must be written in terms of ohm. Are you clear? Now, we are going to vary the value of VBE. Are you clear? The voltage across base and emitter to be varied. The corresponding variation in the base current to be observed. When these two are varying, what we have to do? The one more factor, the another factor, voltage factor to be kept constant. So, write everything within the bracket. And which voltage should be kept constant? That VCE to be kept constant. So, the constant factor VCE can be written outside the bracket. So, this is the exact formula. With the help of this, we are able to find out the input impedance. Now, I will define the input impedance of the transistor. How to define the input impedance of the transistor? Now, I will define, this one may be asked in the 2 mark. Input impedance of the transistor of the NPN transistor in CE mode is defined as the ratio of change in base emitter voltage to the change in base current at constant collector emitter voltage. This is a method of saying the definition. its unit is ohm. Usually the Ri value will be very high. Are you clear? Ri value usually that one will be very high. So after performing the experiment, you can find the high value of Ri in any transistor characteristics graph. Are you clear? So what we have to do? The next step is, after finding the formula, clear, what you have to do? We have to perform the experiment. How to perform the experiment? Here, that VCE is nothing but voltage across collector emitter voltage. That should be set here. Are you clear? By adjusting the rheostat. By adjusting the rheostat 2, we have to set the value of VCE. So adjust the rheostat and set the value of VCE as 1 volt. Are you clear? Adjust the rheostat, adjust the value and set the value of VCE as 1 volt. Its value, the VCE volt, must be more than that of the knee voltage. If it is a silicon transistor, its knee voltage will be around 0.7 volt. Therefore, the VCE value should be more than that of 0.7 volt. Are you clear? That's why I have set the value of VCE as 1 volt. Are you clear? After setting the 1 volt, it should be kept constant, it should not be varied. Now we have to vary the value of VBE. Are you clear? So come to the tabular column. Now by adjusting the rheostat 1, set the value of VBE. Are you clear? Now the first reading that could be taken is 0.1 volt. Note down the corresponding reading. Note the corresponding reading in IB, that is in microammeter. Are you clear? Adjust the rheostat again. Rheostat 1 to be adjusted, the value of VBE to be altered, and it should be set as 0.2 volt. So vary the VBE by adjusting the rheostat 1. Note down the corresponding reading in microammeter, that is base current. So for various values of VBE, the corresponding IB value to be noted. Are you clear? So when this one is varied, this one to be observed. So clear, VBE can be adjusted by adjusting the rheostat 1. Are you clear? Which one to be used to keep the VCE constant? Rheostat 2 to be used to keep the VCE constant. So adjust the VBE, observe the IB reading. You can easily understand while doing the experiment in the lab. Are you clear? So after getting the set of values, plot the value. In the graph sheet, in x-axis, the VBE value to be taken in x-axis, IB value to be taken in y-axis, and plot the value, you will get this graph. This particular part of the graph you will get there at the top of the graph, at very closer to the curve. So clear, this value VCE is equal to 1 volt must be written. Could you understand that? Now, after the completion of this part of the graph, again what you have to do, the rheostat 2 to be adjusted and the VCE value to be set as 2 volt. Instead of 1 volt, there you have to write it as 2 volt. There also in voltmeter, 2 volt to be must be set and it should be constant throughout. Again you have to take the set of reading that is to be taken between VBE and IB. Again you will get the set of values. Again you take this particular set of value, again you draw the graph. This graph is drawn for VC is equal to 2 volt. So this graph is drawn for 1 volt, this graph is drawn for 2 volt. Could you understand? Here the common thing is, in both the two graphs, clear, if you draw a vertical line towards x-axis, you will get the common knee voltage of the transistor. Here only that IB it starts increasing. Are you clear? IB starts increasing. Are you clear? So therefore this particular voltage is called knee voltage. In the case of silicon transistor, knee voltage value will be around 0.7 volt. After that the IB value it starts increasing. Here one important conclusion is it clear, after drawing VCE, we have to go for VCE 2 volt. When you increase the VCE value, clear, what will happen? The graphs that could be seen, that the graph they are in the outward direction. Is it clear? When VCE is increased from 1 volt to 2 volt, the curves, is it clear? It should be drawn in this direction, outward direction of the lesser value. Are you clear? And one more thing is, clear, if you increase the value from 1 volt to 2 volt, IB value decreases. IB value decreases. When this one increases, IB value decreases. Are you clear? These are all the important conclusions that must be learnt thoroughly. Certainly some of the important 1 mark objective question may be asked. Again I will repeat. When VCE is increased, IB it decreases, and the graph that is seen in the outward portion of the first one. Are you clear? If you take the graph, if you take the reading for VC is equal to 3 volt, what will happen? How the graph will be? The graph, that one will be appearing here. Are you clear? So these are all the important thing. Now here I have chosen 2 points in the IB. So clear, this is point number 1 and point number 2. Extend the line. In VCE 1 volt graph, extend the line that cuts in the graph. Here, that point that cuts here, this point cuts here. Find out where these 2 points are intersecting. Therefrom, you can extend, that could be extended towards x-axis. Are you clear? So therefore, this portion that gives you, what is this? Del IB. What is del IB? Del IB means difference in base current. Higher value of base current minus lower value of base current, that gives you del IB. Here you can draw a small triangle. A slope like structure is appearing here, no, and extended. So clear, here one small portion is appearing. Here that smaller value of difference that gives you, what is this? Del VBE. Are you clear? What is del VBE? Difference between the higher value minus lower value, that gives you del VBE. This difference in VBE and difference in IB, both are important. So clear, therefrom only we are able to get the value of Ri. Are you clear? To get the Ri, which two are required? Difference in VBE and difference in IB, both are required. Are you clear? Now look at the formula. What is given here? Ri is equal to del VB divided by del IB is a value that gives you Ri. Now after drawing the graph, so clear, you have to find out the slope. What is the general formula for slope? Slope is equal to slope. What is the general formula for slope? Dy by dx is the formula. Difference in y divided by difference in x, that one gives you, what is this? Slope. But what is written here in the y, so clear, x axis, what is the difference in y? That is nothing but del IB is the difference in base current, that gives you dy. What is dx? In dx, what is the difference in dx? That is nothing but del VBE. Are you clear? So this is the value. After substitution, that one gives you the slope value. Are you clear? But in the formula, input impedance formula, the numerator del VB is there. The denominator del IB is there. So to get Ri, what I have to do? Ri will be equal to reciprocate the slope value. 1 by slope. What you have to do? After finding the value of the slope, that should be reciprocated. After reciprocation, so clear, this value can be rewritten like this. Del VBE divided by del IB. So after finding the slope, what we have to do? We have to reciprocate the slope value. Only then you will get the Ri value. Are you clear? So by that time, which one is kept constant? This one is kept constant. VCE is kept constant. And the value, final value must be written in terms of ohm. That you should not forget. Are you clear? You will get the value, clear, finally in terms of ohm. The value of Ri, that one will differ from transistor to transistor. In transistors, they are available in different numbers. Are you clear? So different transistors, they will possess different value of Ri. Usually the Ri value will be comparatively high, basically in the case of the CE mode. Are you clear? So this is the complete description about input characteristics of the transistor. Therefrom we have found out the input impedance. This is one of the important parameter of the transistor. Understood?